For our last problem, we're going to use Gauss-Jordanian elimination again to solve. Again, I've given you a slightly simpler problem than the one that's originally on the notes. Just this one's simpler. You can definitely do the one I crossed out, but I'm going to show you how to do a slightly easier one. So we want to do our augmented matrix, which is going to be 2, 4, -2, 0, 3, 5, 0, 1. Now, you may already remember from Chapter 9, when you have a non-square system, there is not a unique solution. Okay, so this is going to have infinitely many solutions. You may recognize that already. But that's okay, we can still do this problem. So our goal is to get a 1 right here and to get zeros everywhere else. Now, normally I like to work on getting zeros first, but to get a 1 here, all I have to do is divide everything by 2. And that's not going to give me any fractions, so I'm going to go ahead and do that. I'm going to take half of row 1. So dividing all these by 2, I get 1, 2, -1, 0. And that's just going to make my elimination simpler. Okay, so now I've got a 1 here. My goal is to get a 0 below it. So we want to transform this. I'm going to leave my first row alone. And I need to basically cancel out that 3, so what I'm going to need to do is take -3 times row 1 plus row 2. And again, if you kind of like to sketch in green what you're doing, so I'm taking row 1 times -3, so I get -3, -6, 3, and 0. And I'm going to add that green row to my bottom row. So -3 plus 3 is 0, -6 plus 5 is -1, 3 plus 0 is 3, 0 plus 1 is 1. Okay, so now I have successfully gotten a leading coefficient of 1, a 0 below it. My next goal is right here. I would like that to be a 1 and have a 0 above it. So first, I'm going to turn that into a 1. And I'm going to do that simply by multiplying row 2 by -1. So we're just taking the negative of row 2. Row 1 is staying the same. And this becomes 0, 1, -3, 1. Now, still my goal, get a 1 there, a 0 above it. So in order to do that, I'm going to take a -2 times row 2, and I'm going to add that to row 1. If you'd like to see that in green, I'm multiplying row 2 by -2, so that's 0, -2, 6, -2. I'm going to add that green row to my row 1. Okay. But this second row, we are unchanged there, so let me just rewrite that. Okay, so the green plus row 1, so 0 plus 1 is 1, -2 plus 2 is 0, 6 plus -1 is 5, and -2 plus 0 is -2. So that looks good. I am in reduced row echelon form. Okay, notice I have a 1 as my leading coefficient, all zeros in that column. A 1 is my leading coefficient, all zeros in that column. So now remember, this is an augmented matrix. So this tells me, the top row tells me x plus 5z equals -2. And I also know that y minus 3z equals 1. Now, I told you there was infinitely many solutions to this. So what I'm going to do is, do you see how x and y are very simple to solve for? Which will be good. I'm going to let z be a number, just any old number, a. Then y minus 3z, but remember z is the same thing as a, equals 1. And so when I solve that for y by adding 3a to both sides, I get y equals 3a plus 1. Furthermore, x plus 5z, but remember z is just a, equals -2, and when I solve that for x, I get x equals -5a minus 2. So my solution to this system, x is -5a minus 2, y is 3a plus 1. Boy, it seems like that 2 should be positive. I might have to think about that for a minute. And then z is a. And for some reason, I think I might have gotten a small sign change wrong. I feel like the 2 should be a anyone see my mistake? Anyone? Anyone? What, you're not here. Ah, I see it. You guys didn't stop me. Back here on this step, don't worry, it's just a small sign change. Do you see back on this step when I made everything negative? So this should have been +1, -3, -1. I didn't do it right here. Okay, that should be a negative, which means when I multiply that by a -2, this green should have been a positive, and so that should have made this a +2. No worries. +2, and so that makes +2, +2. Okay, I know it didn't seem quite right for some reason. I apologize for that mistake. Here's your answer.